Albatross spend most of their time at sea, only venturing on land to raise their young. These legendary birds populate the remote Hawaiian islands of the North Pacific, but they face a threat. Plastic washed into the oceans from people living thousands of miles away is killing them. We can see with our own eyes the effect that plastic is having here on the albatross, but there's new evidence that as it breaks down, the plastic in our oceans could be having an impact that's much more far-reaching. A team from the BBC's Natural History Unit filmed here last summer for a series to be broadcast next year. They found turtles nesting in amongst plastic bottles, cigarette lighters and toys. And they found dead and dying birds. Albatross parents unwittingly killing their young by feeding their chicks plastic carried in as they forage for food in the sea. Some chicks die when sharp plastic punches their bodies, others from starvation as their stomachs fill with plastic they can't digest. And you saw carcasses when you were there too, is that right?
Yeah. What we found was every day we would go down to the island filming, and every day there would be more and more carcasses on the beach. Obviously, we can't tell ourselves what it was that killed them, but what we do know from American scientists is that they've autopsied a lot of these birds, and what they found is plastic in virtually every single stomach of a dead bird.
Ellen Hussein was part of the BBC crew that visited the Hawaiian Islands.
So these are examples of the kind of things you can find on the island. Disposable plastic lighters, bottle tops, the arm of a child's doll.
She showed us some of the items scientists have found in albatross stomachs.
There's this really jaggedy bit of plastic. There's lots of different plastic of lots of different origins. There's God knows what that is.
Some of the plastic's been illegally tipped at sea or is litter from fishing. Most comes from the land, from poorly run landfill sites, industrial waste, even the fibres from washing machines. But how does it get here? Floating debris and plastic is carried to the Hawaiian archipelago by giant ocean systems, or gyres, partly driven by air currents. Hawaii sits in the midst of a gyre known as the North Pacific Subtropical High, made up of 4 large clockwise rotating currents: the North Pacific, California, North Equatorial and Kuroshio. The North Pacific Gyre is one of 5 gigantic interconnected systems of ocean currents. Each spirals around a central point, drawing material inwards, which is what carries the plastic to Hawaii. These spirals can also inject material out towards the Arctic and Antarctic, spreading material across the globe over time.
Oceans are all interconnected, and there's this interconnection, which means that a problem that occurs in the Pacific eventually will occur in the Atlantic, in the Indian Ocean.
So just how far does the problem of plastic in the oceans extend? I went to Southampton to see if it can be found in the coastal waters of Britain. Simon Boxall from the National Oceanography Centre took us out to do a bit of sampling.
So we drag this net through the water. The water can escape through the net holes, but all the particles and the plankton are trapped within the net. And they eventually come into this bottle at the end. Well, we're going to leave it out for about 10 minutes, and that will allow us to filter through around about 400 tonnes of water. There's been a lot of research in the United States looking at how the plastic gets into the food chain, and certainly it's been shown that it gets into bivalves, into the mussels and the oysters of the seabed, and it does have an effect on them. They accumulate, they bioaccumulate this stuff, they filter the water, much the same as we're filtering the water now. So they concentrate the plastics, and that does have an effect. It effectively turns some of those mollusks into hermaphrodites. We don't know yet whether that then has an impact on the human food chain, and it's still very early days to find out how far up the food chain these plastic particles go. There we go.
The idea that these plastics can cause disturbing sex changes might sound bad enough, but another worrying effect is beginning to emerge.
So that basically is the filtration of
Right.
just under 400 tonnes of water.
So you can see a few feathers and things.
See a few feathers and things, but in fact, you can actually see a piece of plastic just there.
Yeah.
We need to take it to the lab and have a look under the microscope to see exactly what we've got. Okay.
We can't see chunks of plastic debris like the pieces the team saw in Hawaii. It's tiny particles of broken down plastics we're looking for, because this is where scientists are focusing now.
You can see in there we've got some plankton. We've got some zooplankton, they're the animals. We've got some phytoplankton, they're the plants. You can see the soil particles, but you can also see very distinctive the plastic particles.
With the sharper edges.
With the sharper edges, yeah. And then you can see down here there's some zooplankton tucked in amongst the all the rubbish, the soil and so on. You can see their sort of heads and tails. We know that big plastic has an effect on wildlife, whether it's plastic bags, plastic bottles. But eventually that plastic breaks down mechanically to smaller and smaller particles. And the question is, does that have an impact as well? Some years ago, it was assumed that that was like roughage and it didn't have a major impact. But we know, first of all, that those very small plastic particles can mimic certain things like estrogen. And we know that has an impact. But also, these plastic particles are like sponges, they're like magnets for other contaminants, things like tributyl tin, TBT, and antifouling. And they absorb these materials and effectively become quite toxic particles.
So we know that fragments of plastic are in our oceans, and it appears to be having an effect on creatures in some parts of the world. But there's new evidence about our own food chain. I went to Plymouth to find out more. At the Marine Biology and Ecology Centre of Plymouth University, they study the impact of pollutants on our oceans and rivers, and the creatures that live in them. Marine scientist Richard Thompson was the first to describe the tiny fragments of broken plastics as microplastics back in 2004.
There's two concerns from a toxicological point of view. There's the issue that plastics are known to absorb and concentrate chemicals from seawater. And the secondary question is about chemicals that have been introduced into plastics from the time of manufacture in order to achieve specific qualities of the plastic, its flexibility, or as flame retardants or as antimicrobials. Is there, when we've now got plastic not as whole, intact original items, but as small fragments in the environment, is there the potential for any of those chemicals from manufacture to also be released?
We don't know the answer to that question yet, but what his team is discovering is, as in Hawaii, plastic is making its way into creatures in the wild. He looked at fish in the English Channel, 500 or so across 10 species, including mackerel and whiting, and he found it. In small quantities, 1 or 2 particles per fish.
It's showing that microplastics are quite widespread in the environment, not just in the water column and in beaches, but actually in the creatures that live in some of those environments. So then the next steps really are to take information like that from fish and from other creatures to understand, well, okay, how much plastic, what are the chemicals that might be of concern, what are the concentrations of those chemicals, what are the quantities of plastic, and how does that vary from species to species, in order to understand which particular combinations might create the greatest potential for hazard, because that's what our work is trying to establish at the moment. What potential is there for these microplastics to actually cause harm in the real world?
So is anything being done to cut back on plastic waste? One of the world's largest cosmetics manufacturers, Unilever, said this month it'll stop using plastic microbeads it adds to some shower gels and facial scrubs. But should the plastics industry itself be doing something?
We're unhappy that there's plastics in the ocean. The plastics industry itself, of course, doesn't leave plastics waste on beaches or illegally dump it at the sea. We need it back. It's a valuable resource. We need it back first and foremost for recycling, but also it is a valuable form of heat and power in energy from waste combustion.
We know that the plastic we can see is affecting wildlife in places like Hawaii in front of our eyes. We know that tiny fragments are being found all over the world, and we know it's causing disturbing sex changes in some creatures. It's vital now that more work is done to find out about the true impact of plastics in the wild and what that means potentially for all of us.